Okay, in this video we're going to be doing Calc AB Problem Set 116. The problems and a playlist are in the description below. Let's do it. So we want to evaluate the integral from 0 to 1 of the square root of x squared minus 6x plus 9 dx. So we pretty much know that when we're asked to integrate a square root of something, either it's just going to work out by u-substitution, or probably we should consider doing this graphically. So I'm going to try to factor that thing, and we'll get 0 to 1. The inside is just the quantity x minus 3 squared. So we have the square root of x minus 3 squared. That's the absolute value. So we have 0 to 1, absolute value of x minus 3. Okay, so we can solve this by looking at a graph, right? So when x is 0, we get 3. So all that really matters are the vertex and the endpoints. In this case, the vertex is at 3, which is not in the interval that we're interested in. We're only looking 0 to 1. So we plug in 0, we get 3. We plug in 1, we get 2. And so that's all we're interested in. So we've got this region. That is a trapezoid, so I'm going to find the area of a trapezoid. So it's 1/2 the height, which is from 0 to 1. So 1, the sum of the bases, so that's going to be 3 is one of the bases, and 2 is the other base. So half of 5, 5 over 2. Pretty good question. Should not stump you, but be aware, you try your standard like u-substitution. U-substitution doesn't work immediately. Start to think like, ooh, maybe there's more that I can do. All right, let's look at the next one. Evaluate the integral from pi over 6 to pi over 3 of cosine over sine. So this problem could have said integral from pi over 6 to pi over 3 of just cotan of x, and then you would have to know that cotan is cosine over sine. But I think we're okay here to just try to let u equal the denominator, which is like always the first step of these anyway. You try it, and if it doesn't work, you try something else. But du will therefore be cosine of x dx. This is working out well. I'm going to change the bounds. So when x is equal to pi over 3, u is going to be the sine of pi over 3, which is root 3 over 2. When x is equal to pi over 6, u is the sine of pi over 6, which is 1/2. So we can rewrite our whole integral. We're going from 1/2 to root 3 over 2 of 1 over u du. So 1 over u du is definitely natural log absolute value of u. And then we're going from 1/2 to square root of 3 over 2. So we're going to plug in AP exam free response question. You could basically leave it once you are done subbing in the upper bound and the lower bound. I'm going to simplify this a little. If we have subtraction between the natural logs, that's division within the natural log. So natural log of root 3 over 2 over 1/2, which simplifies to just the natural log of the square root of 3, which again, you could stop at, but that's natural log of 3 to the 1/2. Exponents become coefficients. I'm going to write it as 1/2 natural log of 3. You want to practice your natural log properties every once in a while, because on multiple choice questions, they do come up sometimes. Like you get an answer, but it's not one of the answer choices, and then you have to play around with it. So be advised, it's not bad to practice those. All right, next up, evaluate. I guess we're just doing a lot of definite integrals today. From 1 to 3, quantity x minus 2 e to the 2x squared minus 8x dx. So I'm going to try to make u equal to the exponent of e. There's an alternative approach to this where you let u equal the entire exponential, which is actually probably a better idea. Like in general, that will work on more problems. I didn't originally learn it that way, and so my habit is to always let u equal the exponent. Either way will work, and I have a lot of videos where I do both, so check those out if you're interested. Du is going to be 4x minus 8, and then dx. We don't have 4x minus 8. We only have x minus 2 in the integral, right? So we have x minus 2 and a dx. So I'm just going to divide everything I see by 4, and it will become 1/4 du is the quantity x minus 2 dx. So now I can perfectly substitute. So I'm balancing out that differential to try to make this work for us. I'm going to change the bounds. So if x is equal to 3, u is going to be 2 times 3 squared is 18, minus 3 times 8 is 24, so negative 6. If x is equal to 1, we just get 2 minus 8, which is negative 6. Now this is super interesting because the bounds are the same. So actually, if I had just changed the bounds immediately, I would have realized like the integral in terms of u is just the integral from negative 6 to 6, which is 0. We can write out the integral, but we're still just going to get 0. So this is actually 0. I wasn't really expecting that going into this problem, but, that's interesting. All right, let's look at another problem. Find the volume of the solid formed when the region bounded by y equals secant of x over 4, x equals 2 pi over 3, and the coordinate axes is revolved about the x-axis. So I don't even think I really need to graph this one. Secant is definitely above the x-axis, and it's the only curve, and since we are going from the y-axis to 2 pi over 3, we know we're going from 0 to 2 pi over 3. Basically what I'm saying is I should have drawn a graph, but I didn't draw a graph. You should take a second, sketch a graph. It can really help you. The volume here is going to be pi times the integral from, we're starting at the y-axis, so 0 to 2 pi over 3. So those are the vertical lines that are hemming in your region. When you start at the x-axis and you shoot out until you hit the outer edge of the region is secant of x over 4. So that's our radius. We need to square the radius because we're always doing pi r squared. So we're squaring the radius. We'll get secant squared of x over 4 dx. Okay, so this is perfect, right? Because the derivative of tangent is secant squared. It's not totally perfect though, because there should be a 1/4 on the inside by the chain rule. So I'm going to put a 1/4 on the inside and therefore a 4 on the outside. So we get 4 pi, and then that would give us a perfect tan of x over 4 when we integrate. So you can do the substitution if you want. I think on this one it's clear enough, but if not, show your work. 0 to 2 pi over 3. Now we just got to plug these in, think about the unit circle a little bit. Well, think about unit circle angles, I guess. So we'll get the tan of 2 pi over 12, which is pi over 6, minus the tan of 0. Tangent of pi over 6, in my mind, is the ugly tangent. It's root 3 over 3. Tangent of 0 is 0, which is maybe even the best of the tangents. I really think the tangent of pi over 4, which is 1, is the best of the tangents, but 0 is a pretty good one. So our answer here is 4 pi root 3 over 3. Or if you really want to be kind of weird about it, you could say it's 4 pi over root 3. I'm not going to do that. That's the entire problem set. I hope you found this helpful, and good luck.